Righty. Hey, good morning, guys. Can you guys hear me okay, Chris and Jesse?
Yes, I can.
I've got you.
All right, I can hear both of you guys. Good morning, everybody. We're so excited that you decided to join us today. We know that it's tough to take time out of your schedule, so we really appreciate it. It's really an honor to us that you would choose to take the time to join us today. We really look forward to answering some of the questions that you've already submitted and some of the questions that you'll submit hopefully during this AMA. So as we get started today, I'm going to give you guys just a brief introduction into what we'll be doing. Hold on. All righty. I forgot to put my slideshow back at the beginning. All right. So as you guys know, we're in the SmartDrone AMA today. So kind of what our agenda is going to look like is we're going to talk a little bit about who signed up for this meeting and some of the statistics that deal with that. Is my screen flickering on y'all's end? No? Okay, perfect.
No.
Maybe that'll stop it. We're going to give a bit of an intro into how we're going to do our AMA today, how we get started with drones, like what's the best way, some of the, and our discovery too, an intro to that, as well as a little bit of a workflow and data processing using our processor and also some third-party processors or other processors, as a lot of people would say. So as far as our demographics go, it looks like 22% of people that signed up for this AMA are already using LiDAR drones, and that's awesome. We're excited that you're here. We look forward to any questions that you have about our product or processors or anything like that. 30% of you guys complete 50 plus acres of topographic work per month, which is really cool. And 32% of you guys are using AutoCAD, Civil 3D as your primary CAD software. So kind of the way this meeting's going to work is if you guys look, it might be on the top or bottom of your screen, depending on how you have your Zoom set up, but there'll be a chat, Q&A, and there should be like a raise and lower hand. So if you click that Q&A button, that's going to allow you to submit questions throughout the meeting, and that'll accrue in a list for us. And then we're going to go through that list and basically at each break when we talk about a new topic and answer some of your guys' questions. So our first one here is how you get started with drones. And actually, before we do that, let me have our panel introduce themselves. So my name is Michael. I'm the FAS lead here at SmartDrone. I've been here for about a year, and I've been working with drones for maybe a year or two, and have really been learning a lot and enjoying the experience. Chris, why don't you tell us a little bit about yourself?
Hey, thanks, Michael. So I'm Chris. I'm the Field Application Specialist in the Houston area. I spent 6 years in the Air Force as an F-16 crew chief. When I got out, I went to Embry-Riddle to pursue an education in drones, and I've been working with them and LiDAR/GIS data ever since for the last few years. And I'll pass it over to Jesse Hocker.
Thanks, Chris. Like Chris said, I'm Jesse Hocker. I'm the FAS for Austin. I got my start in the drone industry in the Marine Corps. I was a UAV maintainer for 5 years. After the Marine Corps, I became a pilot, doing some government contracting, and I've been with SmartDrone now for 6 months, learning the rope on smaller Group 1 UAS.
Yeah, I just want to add one thing that I really enjoy about having these FAS. We have a few of them now, and they all come from different backgrounds. And it's so cool to see how Jesse's experience in the military with using drones and Chris's experience in the consumer drone market with another company, as well as his military experience working on airplanes and all that really comes into play and how our company does things. So that's pretty cool, and I really enjoy having that as a part of our team. So I'm going to go ahead and hop back into our PowerPoint here, and we'll get started. So Chris is going to go ahead and give us an introduction into how we get started with drones. What does that look like for you?
Yeah, so two of the biggest barriers that we see before people start to get into drones is cost and experience. A lot of people are under the assumption that getting into drones is going to cost several thousands of dollars, and it can. But when you're first starting out, you can go with a very basic drone that's going to produce great outputs. And so up here on the screen, we've got the DJI Mavic Mini at $400. This is a phenomenal drone to start out with. You're going to be able to generate incredibly high resolution orthomosaics, and most of these drones are going to fly themselves. You're going to plan your mission in office, go out into the field, get your drone turned on, set up with your GPS, and then you're going to press fly. And it really is as simple as that. You can also go with a Skydio 2 kind of upgrading just to get a little more features. But really, it's a really easy entrance into drones. But you're also going to need a drone license before you start doing drone flights commercially. And Jesse is going to be sharing about how you get that license.
Yeah, thank you, Chris. So what does it take to get your Part 107? First of all, what is the Part 107? So if you're flying your drone for commercial use, you're going to need your Part 107 license. It's going to take about 5 to 10 total hours of studying. And that's going to be obviously depending on the person. You're going to need a 70% score to pass, but don't worry, it's the easiest standardized Federal Aviation Administration test that they have to offer. We're very proud to talk about everyone on our team, from our CEO to our HR person, has their Part 107 license. At the most, it's going to cost you $160, sometimes closer to $100. Here at SmartDrone, we provide plenty of free study materials, and if y'all would like to scan that QR code, you can get a free study guide.
Yeah, and I'll keep us on that slide for just a moment, and I can bring us back to that slide at the end if any of you guys would like to take a look at that for a little longer. All right.
And next, we're going to be talking about, what do you need to use a drone? What are you going to need to get started? So first, it's going to be really important you to define, what you're going to be using your drone for, choosing the right drone for the job. Once you have that figured out, most of you are surveyors or civil engineers. You're using CAD softwares. If your PC is running CAD, more than likely your PC is going to be able to handle the data associated with using drones. Some additional things you might need are some other softwares. You're going to need ground targets, GNSS base station, and here are some other programs that you can use that Chris and Michael have a lot of experience with.
Yeah, so Chris, especially Pix4D Mapper, he's been using that a lot in his past experience. Can you give us how long would it take for somebody to learn that, and what kind of resources do they have available to them?
You can realistically learn Pix4D in a matter of half a day to be proficient with it. Pix4D is a great photogrammetric software that's been around for years as a industry standard. Not only is it great software, but they have a massive online community of active users. They're constantly trying to help each other be better photogrammetrists. And even Pix4D support reaching out to them, you're going to get a fast response, and you're usually going to get a really good response that is going to fix your problems. But we also use other softwares in our workflow as necessary. Michael, do you have any words on that?
Yeah, so one software that I've been using recently is Pix4D Survey. And I've been using it and whenever I have a lot of LAS data to deal with. So if I'm flying a job and I end up with like 15 or 20 flights on a job site, this software is able to combine all of that full cloud into one and do a lot. It really accelerates getting to that ground and things like that can take a little bit of time when you do it any other way. Another software that Jesse has learned when he started with us is Cloud Compare. This is one we use in-house quite a bit. Jesse, do you mind talking about Cloud Compare a little bit and kind of some of its strengths and weaknesses?
Absolutely. Cloud Compare is a free open source program that's really great for dealing with large point clouds. You can bring the point clouds and the text files in and edit them as you see fit. You can also bring in the LAS files and then superimpose them on each other, add color to show elevation, and then trim those up for your job site.
Yeah, that's absolutely right. And while it can be a little bit of a learning curve, there's so many functions and features in it. It is a very powerful tool once you get kind of get your head wrapped around it. And of course, the fact that it's free and open source makes it very valuable as well. The last two are Topodot and Global Mapper that we're just going to talk about right here. Both of these are ones that I don't have personal experience with, but some of our customers who have bought our units are using our exports and able to do some more advanced classification of data and things like that using these softwares. Another thing that we're working on building right now is our knowledge base. So that's something you can find on the smartdrone.us website. And it's going to go through and it's going to give you some instructions on how to use our drone, how to plan flights using our drone and our processor. But we're also working on a section over third-party softwares and specifically often how they integrate with our data. But I think you'll find a lot of that information is very general and can be used with a lot of different options when you're just looking for some more information or if you hit a roadblock in something. Kris, do you mind giving us a quick run through of kind of some of our typical deliverables and more specifically, how having different deliverables could help somebody that's getting into the drone world?
Yeah, absolutely. So we decided on 4 different packages, each having their own deliverables inside of them, and we're finding that these are better options than just choosing one package that's going to include everything. You might not need line work. You might not need an ortho mosaic. And so that's why we've individualized each of these packages to be more custom for the customer. But starting with our launch, this is going to be your most basic package with just LiDAR to create your topo. Ascent is going to be LiDAR and ortho for you to make your own line work and create that 3D surface. Cruise is going to have all 2 of those, but we're going to do the line work for you. We're going to go in and mark visually things that we're able to see from an aerial view, like parking stripes, road center lines, curbs, and then your journey. I'm sorry, the cruise isn't going to include your topo, but the journey is going to include all 3 of those. We also have a custom package where if you just wanted line work or if you just wanted a topo, you could reach out to us for that and it would be priced accordingly. But like Michael said, the reason that we've done this is to make it more custom for the client, to not only save them money, but to give them exactly what they want.
Yeah, thank you, Kris. And kind of the way this applies to you, if you wanted to start your own drone program within your business, or even as a private person starting a drone program, this allows just a little bit more delineation between what it is that you can offer. And we found it to come in pretty handy. Jesse is going to give us a quick overview of kind of our workflow and how we collect data. And then Kris is going to show us kind of some line work in CAD that he drew recently. And then we're going to open it up for some questions. So if you guys have any questions based on what we've said so far, go ahead and get those in there and we'll answer them here briefly or momentarily.
All right, yeah, thanks, Michael. So here's kind of a chart of the Discovery 2 workflow. So after you've gone out and you've flown your area and you're done flying, first things you're going to need to do is process that data. After the data has been processed, you're going to then need to QC that data, get it in there, make sure you got everything you needed, make sure you cut off excess data that you don't need, make sure that the processor did its job, remove those off-ground points. Then you're going to assemble your data, whether it's taking that 1 foot into a 25, putting it into CAD, putting those photos into an ortho mosaic into Civil 3D, and then drawing line work, getting your deliverable ready.
Yeah, absolutely. And just to add to that just slightly, this can be used for any processor workflow. So while this is specifically ours with the Discovery 2 and our included processor, I think you'd find you follow these very similar steps using anything. You're going to process it. You're going to make sure that it's up to your standards and up to the standards that your client needs. And then you're going to assemble it in a way that makes sense for your client. Kris, I'm going to go ahead and stop my screen share here and we'll get the Civil 3D drawing that you have up and you can walk around a little bit into what you recently did for this client.
Sorry, I was trying to unmute myself. So this is a job we did a couple weeks ago. We were hired out to for the journey package. That's going to be LiDAR, ortho, and line work. Specifically, the client really wanted to see these cracks in the pavement to start planning repairs. But we were also able to get features marked like these pavement markings, our curbs, our sidewalk. So he really got the whole package and saved not only time in the field, but time that he could have been spent or he could have spent on other projects. So this is going to be really the full enchilada. But this isn't specific to Civil 3D by any means. Any CAD software that you're working with, you're going to be able to work with our deliverables to not only produce this yourself or bring it in after we've made it for you.
Yeah, absolutely. And one of the concerns with this specific job, and Jesse, you can, this was a job that Jesse flew, and then Kris went and drew the line work for us. It probably was safety, and correct me if I'm wrong, Jesse, but they probably didn't want people out in the intersection, using the survey equipment, and having to lock down roads for that long, or have people dodge cars. But maybe Jesse, can you share a little bit more about what they needed this for, kind of those cracks and everything, and why they went to us?
Yeah, Michael, that's correct. The city of Austin was wanting to repair a roadway, and they didn't want to shut down traffic because this is quite a busy intersection. It was a shopping center adjacent to, there was a mall, a Home Depot, a Lowe's, a bunch of restaurants. So it wasn't very efficient to shut down the entire roadway. So I was able to fly. Thankfully, the road wasn't too busy, and we're able to get the data that they needed without having the roadway shut down, without having crew members on the road gathering check shots to get this data. So they were very happy. They were able to get what they needed, save a bunch of time, and make it the whole process safer.
Yeah, thanks, Jesse. Righty. I'm going to go ahead and share my screen back to this PowerPoint again. So our next section is on Discovery 2, but we do have a couple questions. Number one is for Jesse here. So he says, Jesse is in Austin. What's with all the Steeler paraphernalia? So do you have any background there, Jesse?
Hey, great question. Well, I'm from Pennsylvania originally, Central PA, enlisted in the Marine Corps right out of high school. And, I've never let my team go, even though we're doing quite terribly this year. But moved to Texas after I got out of the military. And yeah, the Steelers banner will always be there. Hopefully it doesn't offend anyone.
And then we have another question from the same gentleman. And he says point cloud accuracy from photogrammetry has higher accuracy and density than LiDAR. LiDAR can penetrate vegetation where photogrammetry cannot. What advice, hardware, software, and workflows can you offer to give the best of both worlds? And Kris, do you mind starting off with this one, and then maybe I'll add my 2 cents if we get there.
Yeah, like he said, and he's totally correct. In wide open, flat areas, photogrammetry is probably going to be king. You're going to be able to get incredibly high density point clouds and accuracy out of there, working with that flat ground and open area. But like you also said with LiDAR, you're going to get that penetration into your high vegetation to hit that ground. Really, with our Discovery 2 drone, we're getting phenomenal penetration into the deep vegetation. Even I've been working with LiDAR for a few years now, and there's been a couple areas where I was worried about the Discovery 2 not getting the penetration, and it blew my mind how much ground surface we were really able to capture in even forest type environments. So I would say our drone is going to be the best mapping solution for LiDAR.
Yeah, thank you, Chris. And if I could add to that just a little bit, I would recommend having a drone that does both. And obviously I'm biased, right? We all work for SmartDrone. You know, we all want you to buy our product, but there are lots of great options out there that use both LiDAR and photogrammetry. And there's lots of great options out there too for you to have a separate LiDAR and photogrammetry unit as well. And so I recommend doing your research, figuring out the size of jobs you're looking at. If you're going to be flying large jobs and you just need photo, like a great example of this is where they put trash and such in those big landfills. A lot of people are using wing trucks and EVs and vehicles like this that can get that very accurate PPK solution for their photos. And you're dealing with large open areas most of the time. So you really don't need that LiDAR to get through the canopy, and you're able to be very efficient. And a lot of the surveyors we talk to, especially in here in like the East Texas area where it's lots of pine plantations and things like that, really need a LiDAR drone that's going to be able to get them to the ground with the least amount of work as possible. We highly recommend the Pix4D suite, whether it's Pix4D Survey for your LiDAR or Pix4D Mapper for your photos. Both of those have worked really well for us anytime that jobs are getting really complex or very large scale. Thanks for sending those questions in. If you guys have any more questions, please feel free to keep on submitting them as we go. And now we're going to talk a little bit about discovery and how kind of specifications and things like that. I think Jesse, if you don't mind getting us started off with some of these specifications here.
Yeah, absolutely. So here's a bottom screenshot of the Discovery 2. 50 acres and 15 minutes of flight time. It includes a perpetual license with unlimited self-serve processing, 12.3 megapixel RGB camera, 32 digital LiDAR sensor, dual return. It's also ruggedized, taking 200,000 downward shots per second. Single person operation, can easily fit in the back of a car or truck. And we have some new and improved packaging. And we're going to switch over to the camera to kind of show you what the drone looks like, what the case looks like, and a brief overview.
All righty, so this is our Discovery 2 drone right here. You guys can see it out here on the table. It's a pretty good sized unit. It ends up weighing around 17, 18 pounds with the batteries installed. To install the batteries, they're going to go right in this battery door right here on the rear of the drone. So we're going to simply pop it open. And then there's two spots, one for each battery. And you'll see the yellow plugs on the camera right there that where you plug them in. You plug it in, it's going to go ahead and power on, start initializing, and you'll be ready to fly in about 3 minutes. To secure the batteries, simply close that door and you're ready to go. All of our data is stored both internally and externally. So internally, we have an NVMe drive, which is a very fast and reliable hard drive. That's all the data goes there first. And then we're gonna move that data after landing to a small SD card that you can take out, put in your computer, and transfer the data there. We have our GNSS antenna that's full constellation for that PPK accuracy. We need to pick up those same satellites that we're gonna be picking up with the base station that we'll be using while we're flying. And then the last couple items on the drone itself is to move your arms in. There's a little tab right here. And it might be a little difficult to see because it's the same color, but simply press it in and then the arm is now in place. And to lock it, when it's out, simply move it all the way to the edge. You'll hear an audible click and it'll be secure in place. Then we also have the feet. So it's kind of like an air chuck. If you ever use one of those, you're gonna be able to see it right there. It moves in and out just like so. You push it in, put it in place, and then you twist it until you hear an audible click. And that's all the assembly that needs to be done right out of the box. Just fold the arms out, put the feet on, and you're ready to fly. Additionally, it's going to come with a controller with an integrated tablet, and that's going to allow you to plan your missions on the tablet itself and fly. You're also able to get this software on a laptop if you'd like a bigger screen for when you're going through and planning your flights. All of this is going to be contained in one case. And then additionally, we're going to have a battery case. So this case at the top level is going to include your chargers, which you'll receive two of, two battery checkers so you can make sure you're putting fully charged batteries into your drone, and cables for the chargers. as well as 8 batteries, which equates to 4 flights included with the purchase. And all of this is included for $65,000. We only sell one package, and it's basically everything you need to be up in the air and fly. Alrighty. So now we're going to go ahead and jump back into our PowerPoint. Just like so. And our next screen goes over the collection system a little bit. So I talked about this just briefly with our full constellation GNSS receiving system. We pair that with what's called a Trimble. It's made by Trimble, but it's in a Planix APX15. So this is a combination of an IMU, which measures how the drone is tilted while it's flying, and the GNSS receiver to measure where it is in space. Now we use a GPS base on the ground to apply corrections to this drone. Now an RTK system would apply them real time while the drone's flying. We utilize what's called a PPK system, which means that after we land, we take our base down that was running while the drone was flying, and we take the files off the drone, we put them both into our processor, and that accurately geolocates and applies corrections to all the data on the drone so that we can end up with a good result that we can use. Kris, can you talk about the warranty and what the maintenance schedule looks like on a Discovery 2?
Sure. So when you buy our Discovery 2 platform, it's going to include a 2-year warranty. This warranty is going to cover any single manufacturer defect during that 2-year period. We don't include any spare parts because of the way that the drone is all put together. The tolerances are very tight, and everything is calibrated to the installation specifications. So if there is a part that does need to be replaced, if you send it to us, we'll replace that free of charge. And we'll want you to send it in every 6 months so that we can take it apart, put it back together, fly it, and revalidate it. Again, that's 6 months for 2 years, and those maintenance tasks are free of charge, covered under warranty. As far as what else you need to use the Discovery, you're just going to need what comes with the Discovery. That's going to be the drone, your batteries, and the controller, but you're also going to need your own GNSS antenna. Typically, surveyors and civil engineers are going to have their own antennas. Basically, they just need to be able to record Rhinex observations to be able to put into Opus to get a good solution. Jesse is going to talk a little bit about what you're going to, or how you're going to process the data once you finish your flights.
Yeah, thank you, Kris. So before we get into this next section, we do have a great question from Steve, and he said, maybe you'll get to this, but I would like to hear about the ground control software. That's an excellent question. So we use an open source software called QGround Control. And I'll go ahead and bring up an instance of it on my computer actually and share it so you can actually see what it looks like. But QGround Control is used by many platforms, from hobbyists building their own to many companies are using it, making it look a little bit like their own, and then using it with their drone. So if you look at my screen here, as soon as I get it up, let's see, boom. You're going to be able to see kind of what this looks like. So you're going to get a map. It's very similar to Google Map. All you need to do to make your flight is you're going to click this plan button. You're going to click survey. You'll decide your takeoff area. Let's say I want to fly like this wooded area right here. I'm simply going to click done adjusting on takeoff. And then I can add a polygon. So if I click trace, that's going to allow me to pick each corner. So I can pick here, there, down to here, and then over to here. I can square it up just so we get our flight lines nice and straight. And then I can click done tracing and done with polygon. Now I can set my altitude my trigger distance, which is how often we're taking a photo with that camera, our spacing, which is how apart our lines are going to be. So if we have a space every 35 meters and we're flying at an altitude of 55 meters, that's somewhere around a 75% overlap, which means we should get great data down to the ground in this wooded section here. If we go down here to terrain, we can click it, and that is going to allow us to have the vehicle follow a terrain model that's generated using, I forget the name of the company, but it's a digital terrain model that the drone is able to fly as it's going, and that helps us with trees and things like that. Because you can imagine if you took off from one point, you're going up a hill, well, you're quickly going to run out of your altitude as that hill goes up. But with terrain following, the drone's able to follow that hill. And then you can see this is going to give us the area that we're covering, which is about 15 acres, how many photos we should take, the photo interval, and our trigger distance. As well as at the top here, tell you how long the flight's going to be, so about 9 minutes. And it's a very simple program to use. You can change your angles if you were flying a different shape. We always want those lines to be as long as possible for efficiency. And that's really the basics of how to use QGround Control. So that was an excellent question. Thanks for asking that. And then, you're just giving me there we go. And looks like we have one more question here. Oh, that's the one I just answered. There we go. All right. So we'll get back to our PowerPoint here. And Jesse is going to give a walkthrough of what it looks like to use our processor. So he's just going to explain what each box is, what needs to be present, and how you'd use it with after you flew our product. So in fact, I'm actually going to stop sharing and go ahead and let Jesse explain that with his screen.
All right, if everyone's looking now, you should be able to see the SmartDrone Processor up on your screens. So like the example that Michael was giving, you would fly that area. After the drone lands, you would remove that removable SD card and put it into your computer. Starting up at the top here underneath mission selection, you're going to select browse. It's going to open up a file explorer. You're then going to select the mission that you just removed from the drone and just plugged into your computer. The missions are labeled year, month, date, and time. So you select your proper mission. Going down here underneath coordinate frame, you have your U.S. state plane 1983. Underneath that, you have your zone. I have it set to Texas Central because that's where I live and that's where the most of the work I do. But as you can see here, you have various datums that you can pick from. Underneath that, you have your vertical datum, geoid 2012B, EGM 96, WGS ellipsoid, etc. Your output units. Most of us are using US survey feet, obviously, but you have meters and just standard feet here. Underneath base station here, we have the option for local base station, infield, and smart base. Infield is really useful before you leave a site to just ensure that you collected everything. So that's processing the data without geolocalization to make sure that you didn't miss any areas. Underneath here, similar as above where you select mission, you're going to select browse. You're going to select that Rhinex file that you used on that day for that mission. So any base station that you guys are using that has a Rhinex file that you submit to Opus is what you're going to use here. You're going to tell it to use the coordinate outputs from above for that Rhinex file. This is where it gets really important. It's very important that your northing, your easting, and your height for that Opus corrected point is inputted correctly. If you get those coordinates wrong, you're going to have a failed process with your data, and it's a very common mistake whenever we have the processor fail. Usually the coordinates got inputted correctly, or incorrectly, excuse me. Underneath here, we have room for our check shot tool. This is where you're going to go out, take ground shots with your GPS equipment, bounce it off this LiDAR data to further geolocate and reference our LiDAR data and get an accuracy report. So your CSV file out of your collector for the area that you just flew, you're going to plug that in here, and it's going to process that data with those points in mind and spit out an accuracy report. Underneath that, we have the delimiter to select, comma, semicolon, space. It's very important when you put the CSV file in that you have it northeast up or east, north, up to make sure that you have that correct. Underneath that, we have our processor options. Process LiDAR. The processor is going to spit out a 1-foot grid text file and a 25-foot grid. Over here, you can change it if you wanted a 10-foot, if you wanted a 15. There's a space for additional grid sizes. Underneath that, we have the ortho software being used. So if, for the example that Michael showed, if you are also taking pictures, we have the ability to simultaneously process photo and LiDAR. It's really important after you think you're done to go back through and just ensure that you inputted everything correctly. Do I have the correct .o file for my Rhinex? Did I put in the coordinates correctly? Once you get the warm and fuzzy about that, you're going to go ahead and hit process. And that's about it for the processor. I'm going to stop sharing and allow Michael to get the PowerPoint back up.
All right, thank you, Jesse. And one thing I just want to highlight of that whole thing is that check shot tool. So that's something that we added because a lot of the surveyors we talked to, they're like, well, how do we know this data is accurate? How do we know, like, how can we trust it? And that's a great question. Surveys are very important. The accuracy of the data is very important. So what that allows you to do is take like shots that you took with your basin rover or network rover, and that CSV or text file that comes out of that, it directly compares that to the 1-foot ground filtered result that we generate out of the processor. And it's going to give you the average offset, so how far off you are on average, and then of course your standard deviation, which is how close you fit the model of the ground. So thanks so much for sharing that, Jesse. Hold on. Jesse's screen is still up on my screen.
Is it?
Seems to be I'm experiencing a bit of a bug, but it's not up on the main screen. There we go. Let's save this. All
Good.
right, there we go. Looks like we're running. So Kris, do you mind sharing with us a little bit more basically about what I talked about at that accuracy, and then what accuracy standards we meet with the Discovery product?
Yeah, so like you were saying, it's a hugely powerful tool to better see your accuracy. And so we're inputting our ground truth check shots that we took out into the field, and it's going to compare it against the LiDAR data coming out of our processor to give you your RMSE value on your Z axis. We're finding that in open areas, we're meeting the ASP, we're meeting and exceeding the ASPRS standard for half-foot contours. And in more vegetated environments, we're still meeting our standards for 1-foot contours. So this just gives you a better idea of your data to give you more confidence in it. But like this last line says, use what you trust in the processor. So good data in, good data out, vice versa, bad data in, bad data out. So we want to make sure that what we are putting in is accurate data for it to verify off of. Then we can start using our raw outputs from the processor, such as our point cloud. Michael, if you want to talk about the data classifications and file types.
Yeah, absolutely. Yeah, and that just to add on that is, this RTK equipment and everything, we found it to be extremely accurate. And so if we can make good mathematical, equations and say, oh, wow, we actually line up very closely to these RTK shots over the course of the job, we found that helps us and also helps our customers feel comfortable using our data, their job sites. So yeah, as far as classification goes, we classify ground and not ground. Now there's some programs like TopoDot and Global Mapper that do some really incredible things with the data where they can pull out like small vegetation, medium vegetation, large vegetation, and do what's called ASPRS classification with that. At this time, that's not what we're doing. What we found is that a lot of surveyors really just want to get rid of the ground, the buildings, things like that, and get an accurate model of the ground. The trees, the buildings, things like that, and get an accurate model of the ground. Our outputs are standard. We use an LAS, which is the typical output for a full LiDAR cloud, that has every tree, leaf, and branch. We use XYZ files, which are simply text files like a TXT. for our 1 foot and our 25-foot ground result. The reason we went this route is it allows you to directly import that data straight into the CAD software, whether it's Carlson, Civil 3D, Trimble Business Center. It just makes things really streamlined and easy on that end. And then TIFF is the typical deliverable for an ortho mosaic. As far as getting DSMs or some of these other photo deliverables, we once again will highly recommend Pix4D Mapper because it's very simple to use, and we found that it puts out very high quality results when you're looking for a digital surface model from photogrammetry or a photogrammetry point cloud or things like that. That way you can still use the Discovery to fly it, and you can end up with the photo results that you're looking for. As far as the cost of the processor goes, oh, this is me as well. So the cost of the processor is, of course, included with the Discovery 2. So that's one thing that we believe sets us apart from the market, is that we include a perpetual license with unlimited self-service use on your local machine when you buy our Discovery 2. It's going to classify ground and not ground, as I've mentioned, and it's going to generate those outputs that I mentioned. And we always recommend for our processor and for others that for quality control purposes, it's absolutely necessary to go through that data manually and make sure things line up to what you saw when you were out on the job site. Pix4D Mapper is excellent for creating those full photogrammetric results that we've been talking about some, and it's usually a little under $300 a month. And Pix4D Survey is excellent for working with those very large scale LiDAR jobs. You know, we're talking hundreds of acres where you really don't want to go through it manually as much. It's going to allow that much faster workflow. And then Cloud Compare is we always recommend. Some things Pix4D Survey is not going to be able to keep in, like sharp hills, things like that, with its automated system. And Cloud Compare is a great way to come in, do a final sweep, and bring in some of those things you had to manually cut if there were strange shapes, things that automation doesn't deal well with. And the best part about that is it's free to use. It's open source. So, Chris, you want to talk a little bit about point clouds and how they can be colorized?
Yeah, so raw point clouds out of the processor aren't going to hold any RGB values. Typically, when you bring them into your point cloud software, they're going to be colored by elevation. And so what we can do is, if we have an orthomosaic of the same area, we can colorize that point cloud based on the orthomosaic. That way, each point has an associated RGB value. So when you're looking at the point cloud, you're going to get a better representation of what you're looking at, because it's going to look more like real life. It's a very simple process, and we've got guides on our knowledge base at smartdrone.us. So please don't feel intimidated by all these processes. We're more than happy to walk you through all of these. Absolutely.
And then we do have some general boundaries we recommend for LiDAR and photogrammetry. Anywhere where you can see the sun shining through, like a canopy, is often a place where LiDAR is going to be perfectly acceptable and oftentimes excel. But there are some difficult environments for LiDAR. You know, a lot of times we look at it like, oh, it does everything, right? But sometimes that's not the case. So in tall and thick grass or short and thick shrubbery, like anything that's extremely dense and short, it's going to be very difficult to remove, whether it's us or Pix4D Survey or any of these programs, as well as like swamp and marsh environments. But on the bright side, a lot of these three environments specifically, anytime you're dealing with them, you're often not dealing with a large canopy. Or when you're not dealing with a large canopy, you can go and get boots on the ground and use your GPS equipment. You can get an ATV out there or a boat and be able to take these shots and everything that you need. And then use your LiDAR drone for when you're flying that canopy that's right next to it or something like that. And then additionally, Discovery 2 and some of our competitors will collect LiDAR and photos at the same time. But there are sometimes jobs or missions where you'll come up where it's advantageous to plan a separate flight for the most optimal collection. So an example is we're recently flying a site that had 4-story buildings on it. And we found that we were not achieving the spacing, basically the front and side overlap that we wanted on the camera whenever we were directly over those buildings. We resolved this fairly easily by simply raising our altitude, and we ended up with a great photo result. And we're able to take the LiDAR result from those lower flights and get great accuracy on that end and be able to get a great photo result. I think Kris and Jesse are going to talk a little bit about our RGB outputs, both in our processor and in Mapper.
Yeah, so the SmartDrone processor is utilizing precise PPK solution for generating orthomosaics, utilizing the static base for corrections, and utilizing ground control points to verify the orthomosaic during the processing. It's going to create an output file that you can then use in third-party processor to further clean it up. Kris, do you mind touching on Pix4D Mapper? I know you've used it a lot.
Yeah, so while our processor produces a high quality orthomosaic, there are various other photogrammetric outputs that you might want. And so we would use Pix4D Mapper to generate those additional outputs, whether it be your photogrammetric point cloud, your digital elevation models, whether it's a DSM or a DTM, and then you've also got that orthomosaic coming out of there. In this, we're able to use our ground control points and get it rectified within that processing suite to get it as accurate as possible.
Yeah, absolutely. And one other thing I want to mention is that we are able to use that PPK solution that we use when we process orthomosaics in our SmartDrone processor. We've also built in an output that allows you to use that same PPK accuracy when you're processing in Pix4D. This not only will speed up your processing tremendously, as if any of you have used a PPK photo drone in Pix4D versus a non-PPK photo drone, you'll know that it gets through those steps a lot faster, and it'll get you a result that's much closer and more accurate using less ground targets. And Kris and Jesse, why don't you guys go ahead and tell us, what can some of these people expect in the future from SmartDrone?
So we've been very happy with our hardware solutions. We've been working on it for the last couple of years, and we've been very proud of the performance in the field and based on what our clients are telling us. The improvements that we are looking forward to making in the future are just efficiencies within the software. We're also potentially looking at adding third-party integrations. I know a lot of surveyors and civil engineers use a variety of processing suites, so we want to make it as streamlined as possible for you. So we are working on those integrations in the future. Jesse, do you have anything to add?
Yeah, the firmware would be the life of the drone, and then software updates, will be pushed out when they come.
Yeah, thank you guys. And just one thing to add there is one of the reasons we want to make these integrations really streamlined is we firmly believe that when you buy our product, we want you to have everything you need included with the price. But additionally, sometimes people are using more advanced features and things like that. And so we want to make that available and easy for them to use whenever they want to go to the next level of deliverables for their clients. And so this kind of leads us to asking, and one of our attendees asked this prior to the AMA, is what is the best mapping solution for them? And while that could be a difficult question to answer for somebody, there's some questions that you can ask yourself to tell you what kind of drone you want, or do you need a drone in the first place? What kind of drone would be most useful to you? And then which exact make and model is the one you want, right? So I'm just going to highlight a couple of these questions, and there's many other factors that go into this as well. But are your competitors, in your industry busy when they're using these aerial drones? Are their clients happy with the results? That can be a great indication that a drone is a fit for your industry. And then when it comes to LiDAR and photogrammetry, I think one of the most important questions here is do you operate in heavy canopies or changing light conditions? And so with photogrammetry, while it's an excellent tool, when the sun starts to go down, or if you have a day that's going from overcast to sunny back and forth a lot, that can make it very difficult to get a reliable photogrammetric result. Not to say that photogrammetry isn't good, it just has different use cases. And the LiDAR, of course, excels in canopy conditions. That's where it really shows its value. And then lastly, with SmartDrone versus another drone, one of the things that does set us aside from our industry is having a processor that's included and unlimited self-service use on your local computer. So just keep in mind some of these questions as you're thinking, and that can help you make a decision that's right for your business, whether you go with a photo drone or a LiDAR drone or one that does both. So I'm going to go ahead and cancel my screen share here, and we're going to go over a couple questions that we got. So one was ortho function. Would this be your imagery collected during the LiDAR collection and not an associated photogrammetry mission? So that's an excellent question. And yes, with the Discovery 2, you're able to fly your LiDAR and your photo collections at the same time. That is one thing that makes our drone pretty efficient when you're out flying in an environment that allows for that. The most important thing I want to say today is thank you. Thank you so much for taking the time today to join us. We really, really appreciate it. It's encouraging to us that people are interested in taking the time to join us. And we hope that we provide you some value, some understanding into our industry, and some good ways to start as you're looking into getting into drones, whether photo or LiDAR. If you have any more questions, always feel free to reach out to us via our forms on our website, the email addresses, or our phone numbers that are published on our Google Ads for our business locations. A recording for this will be available on YouTube if you want to go back and look at any points. And once again, thank you so much, guys. And yeah, we just, once again, we really appreciate you guys taking the time to join us today. It means a lot to us, and very, very humble. Thank you.